University of California, San Diego. He has extensive experience in reinforced concrete design and analysis and large-scale testing. He is a member of several ACI and PCI technical committee. Again, unfortunately, Andrew could not do it. He could not make it. He had some family emergencies, and he apologized just a couple of days before. But he sent us all his presentation, and Pedro here is very familiar with his work, and he's going to present all the experiment cell program that he did on his behalf. Appreciate that, Pedro.
Thank you, Tarek. Some of you that know me, for sure you know I'm not Andy Budek. And as Tarek mentioned, I am a little bit familiar of the work that he did. And this work was conducted while he was a PhD student for Nigel Priestley at University of California at San Diego. And one of the nice things about the work that Andy did, it follows very well what Dr. Pantelidis mentioned earlier, that when you do a repair, strengthening, or upgrade, you always need to be worried about that you're not shifting the weakest link to other elements. And I think this presentation touches on some of those key issues. So with that, we can say that for a pile in the subgrade region, that we have some confinement effects due to the soil surrounding the piles. And this is something that needs to be looked into it, and we need to study clearly what is the confinement effects of these types of systems. And the question is, can we build this confinement by literally putting an FRP jacket? I think the answer is most likely yes. And this is the critical issue here. So we have, as Dr. Pantelidis said earlier, we have a weak link there at the pile-to-pile cap connection. And you can have problems related to the anchorage of the reinforcement. You can have shear problems there, and you can have confinement issues. I would say that it's probably simple and easy to probably retrofit that, at least simpler and easier than, for example, regions in the subgrade region. And under a critical moment there, you could definitely develop a plastic hinge there. So the question is then, how do you address that? Now, it's not simple to do this type of test, cost effective, and also what you're going to get from the test. So with this, they model this structure in the subgrade hinge in the laboratory, and they had 3 actuators, and these actuators literally applied the displacements to the pile by this loading system, and that loading system was cleverly designed, in a sense, not to confine the region that they were trying to test. So that's one of the critical issues in the test here. So what they did is that they had there a material there that kind of mimic somewhat the confinement effect that you would have from the soil. This is what I gather from watching this test as they were progressing. And here is the confinement with the glass wrapping. This is the response of the control test unit, and as you can see, so it had this is due to this drop in capacity. It's just due to the large cover concrete that this type of pre-stressed piles have. So as soon as that cover concrete spoiled, you had that sharp decrease in capacity. So that's what you experience from this test, and then just basically a good sound ductile response, and then maybe some buckling or fracture of the transverse reinforcement and the longitudinal reinforcement. So this here is the retrofit application. So you first treat the surface. They applied the sheets. I think we are all familiar with this type of installation, so I'm not really going to cover too much this in detail. And here you can clearly see the loading mechanism, and it had to be in place, was protected. And here is the pile is 20 feet diameter, so it's about ratio 1 to 10. And this is where you will expect the flexural cracks. Of course, symmetric top and bottom, because this was cyclic up and down. So what are the things that you would expect from this type of jacket pile response in response to or in comparison to the control test unit? Higher strength, lower ductility. I would say perhaps. I didn't have an opportunity to discuss this with Andy, but I'm going to take his word for it. Few very wide flexural cracks, failure through tendon rupture after them fraying. And here you have it. So definitely higher strength. So you have higher strength. The ductility that he mentioned in the previous slide, we can actually see that from the test. Now, the question that I have here, and since I'm not Andy Budick, so I guess I can ask the question. Maybe somebody in the audience can share some light. Well, these piles were retrofitted for confinement effect, so you would expect actually to have higher ductility capacity, which we don't experience here. But the tendon, I mean the fibers did not rupture under the confinement effect, so it's kind of very interesting. I think this, I'm asking the question because I think it is a very interesting issue here. And here you have one single crack on the side of the load. So this is the last of the loading system. So there was a sequence. And what happened? Well, the jacket made the whole pile, and we're talking about the confined core leading to higher strength. And this is where I think it might contradict then why not higher ductility since you are looking for confinement. And since the covered concrete is so wide, but it's something really interesting, and I'll definitely get in touch with Andy and see, because I think it is a very interesting issue here. So the high tensile strains in the jacket placed a high clamping stresses on the pre-stressing tendon. So this was a pre-stressing tendon. Maybe the lower confinement, the lower ductility maybe has something to do. There was pre-stress in the tensile zone. Also, the high clamping pressure forced inelastic strains into the regions where the flexural cracks existed, and then the tendon rupture at the flexural crack. Some of the tensile strains, so clearly in the steel, so clearly, this is in the jacket, so quite high. And then the ruptured tendon, the location of the ruptured tendon there and there. As you can see, it's basically just fracture and the flexural crack. Of course, this is after test and removal of the retrofit. Here's the positions of the flexural cracks and where they had the high tensile strain in the jacket between the cracks. The rotation demand in the plastic hinge has to be accommodated by the development of high tensile strains in the reinforcement. So some of these conclusions, I think we have seen them before, and so they are very well with matching with previous research. The control pile, so the unjacked pile, had many closely spaced flexural cracks through the plastic hinge, and the tendons in the tension zone could slip and spread the strain demand over a longer length of the tendon. So basically you have a spread of plasticity, and the jacket pile, large strains were forced into shortened tendon lengths at the cracks, because now you cannot spread those cracks, of course, so you're basically concentrating all the tensile strains in a very single crack instead of more widely spaced cracks. So this makes total sense and is within what you would expect. And the comparison of the pre-stressing tendon strain, the areas under the strain profiles will be equal for a given rotation demand. So once again, these are things that we would observe before, that we had observed before. So some conclusions. And the tensile strains can be carried around the circumference of a circular FRP jacket. These tensile strains enhance tendon bond and force inelastic strains into the areas where flexural cracks exist. Sorry for reading this, but I think you understand why. And the pre-stressed pile ductility is enhanced by allowing tendon bond slip over appreciable tendon length. And last, the FRP wrap to simulate soil confine for a pre-stressed pile is a bad idea. So so it's kind of interesting conclusion there. Is a bad idea. So I guess it goes back to his original question title of the good, the bad, and the ugly. So I think what he meant is the bad, but I have some reservations maybe in that conclusion. And if there's any questions from the audience related to this, I will entertain, or maybe if you have some light into this system. Dr. Pantelidis?
Pedro, I'm not very familiar with this, and I know you're not either, but I think I would say wrapping a limited length may be a bad idea.
Right.
But what if you wrap the whole length? It may not be a bad idea.
Right, right.
So maybe what he did was a bad idea, but maybe in a future test we should correct the FRP scheme. Maybe that would become a good idea.
And maybe, I mean, you're pointing a very good, interesting, because that might be the reason why he actually had lower ductility, because he was so short length. And excuse me, there's another gentleman there already. Yeah.
Well, I noticed the large cracks occurred within the zone of the wrapping that was installed, but I wonder what effect and how much longitudinal wrapping it would take to mitigate the larger cracks and spread the cracks out again. You might go with two-directional wrapping that would help control that cracking and spread it out. That might spread it out over a longer zone.
Okay, I will tell that recommendation to Andy. That's a very good point. Andy?
Yes, I think that I can understand the curves you showed, because probably looking at the photographs, he got a big crack in the on the tensile part in the wrapped zone. So probably what happened is he's changing the mechanism from compressive failure in flexure to tensile failure in flexure, and so now it's moving, it's protecting concrete, which is on the pink curve, and now it's going into a tensile failure where, due to the presence of the tendons, he cannot get too much ductility. So it's improving the strength, but he cannot get more ductility. So to me, the only solution would be what was suggested, to add longitudinal fibers.
Right.
To increase also the tensile capacity on the tensile part, not only on the compressive part.
No, I agree. The only thing is that you see that drop there. I don't know if that drop was just because the test was stopped there and he was reloaded at that location, or was it spalling of some form of the cover concrete. I don't have enough. Unfortunately, I just got this presentation early this morning, so I apologize. I didn't have time to study, but those were the things that kind of, interest my my curiosity. Any questions? With that, I will then go ahead and introduce the next presenter. Thank you.